September 2015 from Mpumalanga. Question 8. Grade 12 learners conduct an experiment to determine the internal resistance of a battery. The learners are divided into two groups, and each group receives the following circuit components: a battery, a rheostat, an ammeter, a voltmeter, connecting wires, and a switch. 8.1. Explain the term internal resistance in words. So this is the resistance that opposes the flow of charge within the battery. 8.2. Draw a circuit diagram by making use of the above mentioned components to show the experimental setup. You'll have a battery, and then you'll have an ammeter, a rheostat, and then a switch. So a rheostat has that, and then an ammeter, and then a voltmeter across the ends of the battery. So that should be your setup. The battery is there, a rheostat is there, voltmeter we do have, connecting wires, and a switch. 8.3. Group 1 uses battery 1 with an internal resistance of R1. Group 2 uses battery 2 with an internal resistance R2. The results of each group are shown in the graph below. Refer to the graph and state one quantity of the batteries that is the same. The EMF is the same. When the current is 0, whatever is registered by the voltmeter there is the value of your EMF. So the EMF is the same. Explain why the reading on the voltmeters decreases as the current increases. Use an applicable equation for the explanation. We will use this equation. So this IR signifies the external voltage, and then this signifies the V lost, or the internal voltage. So they say that we should explain why the reading on the voltmeters decreases as the current increases. Well, we know that the value of the EMF is constant, as well as the internal resistance. So when the current increases, R external should what? Should decrease. That we know. Okay, so as the current IR, or the V lost, increases, and then since the EMF doesn't change, V external or IR is obliged to decrease. We can use values so that you can see what this means. So the value of the EMF is 12. Let's just say this is 12. And then let's just say the internal resistance is a 1. So we said the EMF and then the internal resistance, they do not change, which means even if when the current increases, the EMF and the internal resistance will always be the same. So let's just say the current here was 0.5, and then this was V external. So for this part, V external is going to be 12 minus 0.5. So I'm getting 11.5. This is V external. Okay, so now let's just say that we are increasing the current. So we will increase the current there. So the EMF is still 12. Then V external we are trying to find that. And then let's just say the current now is 1. The internal resistance doesn't change. So V external should be equals to 11.0 volts. So as you can see, as you increase the current, the value of the V external decreases. So I hope that makes sense. 8.5. Which group, 1 or 2, uses the battery with the highest internal resistance? Explain the answer by referring to the graph. The slope of the graph or the gradient will give you the value of your internal resistance. So the graph with the steepest, the graph that is the steepest will give you the highest value of the internal resistance. So that will be group 1. Because the graph is steeper. Question 9. A 8 ohm resistor, a light bulb, and a rheostat are connected to an 8.4 battery with an internal resistance of 0.4 as shown in the circuit diagram below. The power of the light bulb is 8.1 watts. The rheostat is changed until the ammeter shows a reading of 1.5 when the switch is closed. The EMF is equals to 8.4 volts. Internal resistance, it's 0.4. And then the current is equals to 1.5. Okay, so this side is the positive, this side is negative. The total current is going this way. At the node, the current will be divided. So we'll have I1, we will have I2 this way. The current will combine again to be I total, and then we'll have I total back into the battery. 9.1. Calculate the resistance of the light bulb. So we have the total current, and then we also have the power of the bulb. We said that through the bulb or through A, that will be the total current that's passing there. So power should be equals to I squared multiplied by resistance. 8.1 should be equals to the current is 1.5 squared multiplied by the resistance. 8.1, 1.5 squared. So that's a 3.6 ohms. 9.2. Calculate the resistance of the rheostat when the reading on the ammeter is 1.5. Like always, we'll try and use 2 different methods to see if we get the same answer. So this is option 1. We are given the value of the EMF. We have the total current. We can try and find our external. The internal resistance is given as well. So this is 8.4. The current is 1.5. That's what we are trying to find. 0.4. So R external should be equals to I am getting 5.2 ohms. These two are connected in parallel. So we need to find the effective resistance of the parallel combination. R parallel is equals to the first resistor, which is 8, multiplied by the second one, which is the rheostat. And then we divide by 8 plus R. So for the top, we find the product, and then in the denominator, we find the sum. Now our circuit will look like this. So this will be the parallel combination, and then this will be R of the bulb. So these two are connected in series. So R external should be equals to R of bulb plus the parallel combination. R external is 5.2 and the R of bulb is 3.6. R parallel is 8R all over 8 plus R. 5.2 minus 3.6 times 8. Therefore, should be equals to so this is 5.2 minus 3.6, which is 1.6. 1.6 times 8, 12.8. And then this part, it should be 5.2 minus 3.6. So that's 1.6 R. So 12.8 over 8 minus 1.6. So I'm getting a 2. That's 2 ohms. Let's try the other method. So we currently have R external as well as the total current. So you will first use that to find R external, and then you'll continue from there. So we are trying to find V external now. V external should be equals to I total multiplied by R external. So the total current is 1.5, and then R external is 5.2. So I'm getting 7.8 volts. And then the parallel combination will have the same potential difference but different currents. Let's try and calculate the potential difference. So our circuit will look like this now. So we will have R parallel, and then we'll have R of bulb. And then we know what V external is. Let's try and calculate the potential difference across the R of the bulb. So the power should be equals to V squared over R. The power is 8.1. The resistance is 3.6. V should be equals to 8.1 times 3.6. Find the square root of that, so that's 5.4 volts. And then we know that V external should be equals to V parallel plus V of bulb. This is the V of bulb. V external is 7.8. V parallel we don't have. The V of bulb is 5.4. So V parallel should be equals to 7.8 minus 5.4. So that's a 2.4 volts. So now we have the potential difference that passes through, that's measured across the ends of R parallel. So we can find R. So we'll say R parallel should be equals to the voltage through the parallel combination all over the total current. R parallel is 8R all over 8 plus R. You remember from that. V parallel is 2.4 and the total current is 1.5. So this is 8 times 1.5, which is 12R, and then 2.4 times 8, that's 19.2, and then that's plus 2.4R. So this is 9.6R, which is equals to 19.2. Therefore, R is equals to 2 ohms. 9.3. The rheostat is changed so that the resistance of the rheostat increases dramatically. 9.3. How will the following readings be influenced? Write down only increases, decreases, and remains the same. So we are increasing the value of the rheostat. Whenever we increase one resistor in a parallel combination, the R parallel will go up. So this whole thing is going to go up, and then we're going to add it with that. So R external should go up. So the external resistance increases. That's the first thing. Goes up. And then the current decreases. And then we said when we have that, whenever the current decreases, that will go up. So V external should go up, and then V internal should go down. Let's answer the question. The total resistance in the circuit, so it increases 9.3.2. The value of the EMF, so the EMF doesn't change, so that it remains the same. It doesn't matter what you do to the circuit, the EMF and the internal resistance will never change. They're reading on V1. So V1 is connected across the battery, so it increases